Final problem in this classwork starts by telling us, suppose the mean number of hours a college student works per week is 18 with a standard deviation of 6.3. A sample of 33 college students is taken. So again, I'm going to pull out the key details here. The mean number of hours, or mu, is 18. The standard deviation, or sigma, is 6.3. And the number of students we're looking at, or n, is 33. When I look for the probability that one student works less than 15 hours, I use the original formula. Z equals 15 minus 18 over 6.3. I put it into my calculator. 15 minus 18 divided by 6.3. And that gives me negative 0.48. I take that p-value, or I take that z-score, to my sheet to look up the p-value. I'm on the negative side. Negative 0.48 gives me a p-value of 0.3156. P equals 0.3156. Since it's a less than question, that is the correct answer to the problem. When I go on and do part B, here it's asking me about the mean of the sample, so it changes the formula slightly. It's still 15 minus 18 on top, except now on bottom, instead of just 6.3, it's 6.3 divided by the root of n, in this case 33. So if I put this into my calculator, I find that 6.3 divided by the root of 33. I now get a z-score of negative 2.74. This new z-score is looked up in my table. Negative 2.74 gives me a p-value of 0.0031. Again, since it's a less than question, that is the correct probability that I'm looking for. In part C, I'm now trying to do more than 17. So my z-score formula on top, I put 17 instead of 15. Otherwise, the bottom is the same. It's still the standard deviation 6.3 divided by the root of n, 33. When I put this into my calculator, I get a z-score of negative 0.91. In the table, that points me to a p-value of 0.1814. If this had been a less than question, I could stop there. Because it's a more than question, I have to take 1 minus that p-value of 0.1814, and that's how I get the correct answer of 0.8186. Final question, again, is the hardest. I'm going to do this the way where I only find the left-sided value and double whatever its table probability is. So here when it says find the probability the mean of the sample differs from the population mean by more than 1 hour, I'm going to start by taking the population mean, 18. I'm going to subtract 1 hour from it. That gives me 17. Good news, we already found the 17 in the problem above. So we know that the probability of getting something less than 17, or this shaded area here, equals 0.1814. Now we could add 1 to it, find what 19 is, find the shaded area to the right of 19, and add them together. But because the table's symmetric, I don't need to go through finding that extra z-score. I can assume, as is always correct, that on the other side of the table, this shaded area also equals 0.1814. So instead of going through and finding that using a z-score, 1 minus table value, if all I do is use this left-sided shaded area and say the right side is the same, I can get to the correct final answer by doing 2 times 0.1814, which leaves me with 0.3628, which is the correct answer to that final question.